Hey guys, in this lesson we would be doing applications of dot and cross product. Before doing the applications, some important things we have to remember is that if you're asked to find out work done, we use dot product. So work done is always equal to dot product of f vector and d vector. So we would be taking f magnitude multiplied by d magnitude cosine theta, and theta will be the angle between force and displacement. Next thing we have to remember is whenever we are finding the area, be it area of a parallelogram. So if we're given parallelogram like this and we are given vector A and vector B, we have to find out the area of this parallelogram. We always do cross product of vector A and vector B. Next is if we are supposed to find out the area of a triangle and we are given three vector sides of a triangle, let's say vector A, vector B, vector C, we do cross product of any two sides and then we divide it by 2. And that would give us the area of a triangle. Now for finding the area of triangle, they can either give you the three vectors or they can give you three vertices of the triangle. So if you're given three vertices of a triangle, let's say we're given A, B and C, then we would use point A, B and C and find out any of the two vectors. So we can find out vector AC, we can find out vector AB, and we have already learned in the previous video lessons how to find out vector values or vector components when we are given the coordinates of the points. So once we get vector AC and vector AB, we would multiply them using cross product and divide it by 2, and that will give us the area of this triangle. There is another thing that we can find out using cross product, and that is torque. Torque is a rotational force, and torque formula is equal to force multiplied by, and the multiplication that we're doing, the cross product multiplication, length of the object on which the rotational force is applied. And if we're given the magnitudes, we would take the magnitude of the force, length of the object, times sine angle between the force and the object whose length we are taking. Let's quickly summarize. Work done is drawn out from dot product. We use cross product to find out the area of a parallelogram, area of a triangle, and torque. Torque is the rotational force. Formula is force multiplied by the length of the object at which the rotational force is being applied. If you're given the magnitude of the two, force and the length, we multiply them and multiply by the angle between the force and the length. Let's do some questions for the sake of practice. Let's take the first question up. So let's say if you're given the question, vector A is given to us in component form -1, 2, 4. Vector B is given to us as 3, 4, 3. We have to calculate the angle to the nearest degree between vector A and B. Now we know angle can be found out using dot product or cross product, and we know dot product is easy. So let's go with dot product. Dot product of A and B is A dot B, which is equal to A magnitude multiplied by B magnitude multiplied by cos theta. Theta is the angle between A and B, so if you want to get this theta, we would isolate theta. We would be left with A dot B divided by A vector magnitude times B vector magnitude, and the whole thing will be cos inverse of to get the angle theta. So here what we did was just isolated theta. Now let's find out all of this. So let's first find out what is A dot B. Let's do it here. We know A dot B is very easy. All we have to do is just multiply x with x, y with y, z with z. So -1 times 3 is -3, plus 2 times 4 is 8, plus 4 times 3 is 12, and we are left with 17. So we know A dot B is now 17. Now we want to find out the magnitude of A and the magnitude of B. So if you're given vector A, the magnitude of vector A would be -1 square plus 2 square plus 4 square and then square root everything. We would be left with 1 plus 4 plus 16, which is equal to square root 21. Similarly, we can find out the magnitude of vector B, and that would be equal to 3 square plus 4 square plus 3 square. Square root the whole thing, we get 9 plus 16 plus 9, and that is equal to square root 34. Now we would sub in everything that we have got. We've got vector A magnitude as square root 21, and we've got vector B magnitude as square root 34. So let's put this all together. All we have to do is find out cos inverse of 17 divided by square root 21 times square root 34, and that would give us angle theta. Let's put this all in the calculator and see what we get. And the final answer that we get is 50.5 degrees. or we can write it as theta equal to 51 degrees. So this is how we work to get the angle given the two vectors in component form. Let's do the next question, and the question says, for what values of m are the vectors x and y perpendicular? We know the two vectors are perpendicular when their dot product is 0. So when x dot y vector is going to be equal to 0, they would both be perpendicular to each other. So all we have to do is just put their dot product equal to 0 and solve for m. We know x vector is m negative 3, dot product with y vector, which is m negative 3 6, equal to 0. Now for finding the dot product, we just multiply the respective coordinates. So m times m is m square, plus m times negative 3 is negative 3m, and negative 3 times 6 is plus negative 18, which is equal to 0. So we get m square minus 3m minus 18 equal to 0. Now we have to solve for m, and we have a quadratic equation, so we can either use quadratic formula or we can use factoring. Here, because factoring is going to work, 6 times 3 is 18, and then 6 minus 3 we get a 3. So our result will be m minus 6, m plus 3 equal to 0. We put each factor equal to 0, we would get m minus 6 equal to 0, so m is equal to 6. And when we put m plus 3 equal to 0, we get m equal to negative 3. So these are the two m values that would give us the dot product of x and y equal to 0, and for which x and y would be perpendicular. So we can either put an m as 6 or we can put an m as negative 3. Let's do another problem, and that's an application of cross product. Next question is, determine the area of a triangle if we are given points A, B, and C. These are the 3 points that form the triangle. We know area of a triangle is the cross product of the vectors, but first we have to create the vectors because we're just given the points. So let's say we make this into a triangle. We're given point A, we are given point B, we're given point C. Let's find out vector AB. Coordinates of A is negative 1, 2, and 1. Coordinates of B is negative 1, 0, and 0. If we want to find out the vector coordinates of AB, we would have to take the coordinates of B minus, we would do the coordinates of A. Negative 1 minus negative 1 gives us the x coordinate. To get the y coordinate, we do 0 minus 2. Z coordinate, we do 0 minus 1. And we get negative 1 plus 1 is a 0, minus 2, minus 1. And this is what we get for vector AB. Similarly, we can get vector AC. C coordinates are 3, negative 1, and 4. So we would do 3 minus negative 1, negative 1 minus 2, 4 minus 1. And the result is 3 plus 1 is 4, negative 3, 3. Now we've got the two vectors. Formula for finding the area of triangle is vector AB multiplied by vector AC using the cross product divided by 2. We are given vector AB as 0, negative 2, negative 1. So we would separate them out as x, y, and z. We are given vector AC as 4, negative 3, and 3. We need to find out what is the cross product of vector AB and AC. This is our x, y, and z. So to find out the x value, we'll use y and z. Negative 2 times 3 is negative 6. Minus negative 3 times negative 1 is a 3. To find out the y value, we'll do z multiplied by x. So negative 1 multiplied by 4 is a negative 4. Minus 0 multiplied by 3 is a 0. To find the z value, we'll do x multiplied by y. So 0 multiplied by 3 is a 0. Minus 4 multiplied by negative 2 is a negative 8. And the result that we get is a negative 9, negative 4, and an 8. Now remember guys, when we have to divide it by 2, dividing by 2 technically means you're multiplying by half. So basically you're just doing the scalar multiplication of vectors now, and the result that you get is a negative 4.5, negative 2, and 4. Because we need to find out the area, we basically need the magnitude of this. So the final answer area is going to be the magnitude of this. And we'll do x square plus y square plus z square, and then we'll take the square root of the entire thing, and the result that we get is 20.25 plus 4 plus 16, and when we take the square root of the entire thing, the result we get is 6.34. Because we don't know the unit, so we'll put unit square. And this is how we get the area of a triangle given the coordinates of the vertices of a triangle.